transmitter release. The transmitter is stored in the pre-junctional nerve endings within the synaptic vesicles. So the transmitter is stored in the nerve endings of pre-junctional nerve within the which is located inside the synaptic vesicles. These nerve impulses promotes the fusion of vesicular and axonal membrane through calcium entry, which fluidizes means it softens the membrane, and all the content in the synaptic vesicles are elucidated in the junctional cleft. The release process can be modulated by the transmitter itself and by the other agent through activation of the specific receptors located on the pre-junctional membrane. The second one is transmitter release. The transmitter means the transmitter which is located in the pre-junctional nerve endings within the synaptic vesicles. So these nerve impulses promotes the vesicular fusion and axonal membrane through the calcium entry, which fluidizes the membrane, and the content in the synaptic vesicles gets excreted from the junctional cleft. This release process is modulated by means of an transmitter itself or by other agent through activation of specific receptors located on the pre-junctional membrane. And the third one is transmitter action on the post-junctional membrane. So the released transmitter from the pre-junctional membranes combines with a specific receptor in the post-junctional membrane, and depending upon its nature it produces EPSP or IPSP. EPSP means excitatory postsynaptic potential or inhibitory postsynaptic potential. In third step, the transmitter which is released from the pre-junctional nerve endings is combined with the receptors in the post-junctional nerve endings and produces excitatory postsynaptic potential or inhibitory postsynaptic potential. What is excitatory postsynaptic potential? There is an increase in permeability to the cations. This leads to potassium and calcium influx and causes depolarization followed by calcium efflux. So the ionic movements are passive. Wherein IPSP, here the increase in permeability to the anions, so the chloride ions move in and tend to hyperpolarizes the membrane. So an IPSP is generated. The fourth step is post-junctional activity. A supra-threshold of excitatory potential synaptic generates a propagated post-junctional action potential, and which results in nerve impulses in the neuron, thus leads to contraction in the muscles or secretion in the glands. If an IPSP is coming, which will stabilizes the postsynaptic membrane or post-junctional membrane, which will resist the depolarization stimuli. So in fourth step, a suprathreshold frequency of EPSP generates a propagated post-junctional action potential, which results the nerve impulse in the neuron that leads to a contraction of muscles or the secretion of glands. If an IPSP is coming, which will stabilizes the post-junctional membrane and resist the depolarizing stimuli. The last one is termination of transmitter action. The transmitter is either locally degraded or partially taken back into the pre-junctional neuron by active reuptake or partially diffuses away. The last step is the transmitter, which is either locally degraded or partially taken back into the pre-junction neuron by active reuptake or partially diffuses away. So the next one is co-transmission. What is co-transmission? It's a transmitter, co-transmitter, which is stored in the pre-junctional nerve ending along with the primary transmitter, but in the separate vesicles. The co-transmitter is stored in the pre-junctional nerve endings along with the other transmitters, but in the form of separate vesicles. These impulses releases both transmitters simultaneously and acting on its own receptor, and the co-transmitter modifies the responsiveness of an effector or its substituents for the primary transmitter. The nerve impulses releases both transmitter simultaneously and acting on its own receptor, where the co-transmitter modifies as the responsiveness of the effector or its substituents for the primary transmitter. Thank you.